We got signals. This is for the 5 gigahertz transmit chain. We have a signal at 5 gig, and we're concerned about second harmonics, among other harmonics, of course, but the second harmonic being especially dreadful. So we don't want to desense our receiver. All right, should we filter here? This is coming from an SDR, so we have some options. That's a question. The first stage that we're talking about is the power amplifier. And Bill Warner proposed using a Cree part. And there's its stats. It gives us 40 dBm at 6 centimeters and 20 dBm at 3. It's spec'd to give 10 dB of gain. So in order to get 40 dBm out, you'd need at least a 30 dBm input, I think. The next alternative that the group came up with was Skyworks, a Skyworks part. And the measurements are 11.5 dBm in gave 34.5 dBm out. And that's not bad. There's been some attempts to find out the second harmonic, not seeing a big problem here. Another nice thing about this part is that it runs on 12 volts, and the Cree part requires 28. Now we should talk about what these PAs are doing. They're amplifying signals that are probably going to come from an SDR. And SDRs have output powers that are pretty low. For instance, the Hack RF at 6 gigahertz is going to give you an output power of 10 dBm, negative 10 dBm. That is a negative. And they recommend an amplifier and a bandpass filter in order to put it on the air properly. In general, you're going to see low output power from SDRs. That's just a hallmark of this type of architecture. Now, in contrast, some of the lab-grade SDRs that we have to work with are the X310 and the B210. And the X310 can produce 20 dBm output, and the B210 greater than 10 dBm. It gives you a little bit more to work with, but those aren't really SDRs that you're going to put into a working radio, unless you have more money than sense. Okay, so that's the status. If you have negative 10 dBm to work with, then how do you get the Skyworks to behave? You're going to have amplification before your PA. All right, and we've also considered the fact of whether or not we need low-pass filters to knock down any second harmonics. And one of the proposals was using 2 low-pass filters from mini circuits in a row. Now, if you're downlink constrained, then filter losses are put on the transmitter, and you pay for it by more amplification. And we are indeed downlink constrained. All right, so if you need any filters, the next stage would be your feed. And we have 2 feeds that we're looking at for the dual band setup. The WB5LUA has a negative 70 isolation from 6 centimeters to 3, and Paul Wade's simulations show negative 80. And so where does that come into play? Well, here's a sketch of a feed. And you can see that here's our 5 gigahertz signal coming in, and the isolation to where we're receiving our own signal is negative 70. So here's a drawing so far, and we're talking about whether or not we then need to add filtering here. And the answer in general we think is no. Unless there's no other choice, mainly because as a downlink limited system, you really don't want to put any more losses on your receive chain than you absolutely have to. And we actually think we might be able to get away with 1 low-pass filter instead of 2 using the PAs that we've been talking about. Negative 70 from the feed, and if we use 1 of the low-pass filters from mini circuits, then that's 108 dB with a 1.5 dB insertion loss. Okay, and there's other questions. Do we need a bandpass filter at the output of the SDR as well? And that's good practice, and we are looking at it, hoping to find out pretty soon.